Okay, let us see. We'll see moment distribution problems, some more kinds. Okay, so let us see a two-spanned beam like this. Two-spanned beam. Okay, A, B, C, and let us take central point load for both spans. 30 kilonewtons, 20 kilonewtons. Let us take here 3 meter, 3 meter, and here 2 meter, 2 meter. How to analyze this beam, we will see. Here, very simple. First, we need to fix the spans. Separately, you need to fix the spans like this, like this, like this, and like this. You fix the spans. Then apply this load. 30, 3, 3, 20, 2, and 2 meters. Okay. Now here we can find fixed moments. What is the fixed moment here? P by PL by 8. So PL by 8 means how much? PL by 8. 30 into L is here 6 by 8. That equal to 22.5.
22.5.
Here also 22.5. Here in this case, same PL by 4. 20 into L is 4 by 8. That equal to 10. So 10 here. So in this scenario, the deflection curve will be like this. Like this. That means everywhere zero slope at support, right? At A, zero slope. At B, zero slopes. At C, zero slopes. But actually, the structure may have a deflection curve like this. It may have like this, we don't know. That means at B, if you observe, some slope is there. Some slope is there. But what kind of slope is there? If you see BA span or BC span, same amount of slope will be there on the deflection curve. Same amount of slope. But we have fixed here. But to make that slope, that means after fixing this one, we need to rotate at B these two spans BA and BC by same amount we need to rotate. How to rotate by same amount? That means movement. See, actually here at B, if you see, net moment is not there internally. I mean, externally net moment is not there. Externally, no moment is there. But you observe here the 22.5 and this 10. 22.5 is clockwise, 10 is anti-clockwise. Net moment is how much? Net moment is 12.5 clockwise, right? That means it is like this now. I will draw. $22.5. Here net moment is 12.5. 22.5 clockwise, anti-clockwise 10. Net is 12.5. Here 10. This is 6 meters. This is 4 meters, right? Like this. Now we need to rotate it by same amount both sides. That means the net moment whatever is there externally, anti-clockwise we need to apply. So let's see anti-clockwise for like this something and like this something. Suppose this amount is suppose this is some x amount. Let us assume this is y amount. So that means x plus y must be equal to 12.5. So how much is x, how much is y? How to apply that one? What ratio we need to distribute? We need to distribute the 12.5 in the stiffness ratio. So stiffness of, that means KBA stiffness is how much? 4A by L. Let us assume both spans are having same flexural rigidity. So 4, because far end is fixed, 4A by 6 is the stiffness of KBA. Stiffness of KBC equal to 4A by 4. That means x is to y, whatever movement we are, distributing, that is sharing, must be in the ratio of stiffness. Y means to make both sides same slope. That is the logic here. We need to understand the logic. Okay, to rotate the beam on both sides same amount, we need to apply the moment in the stiffness ratio. So x is to y must be equal to KBA is to KBC. That means x is to y equal to 4A by 6 is to 4A by 4. That is equal to x is to y equal to, that is actually 4 is to 6, right? Or 2 is to 3. 2 is to 3. By dividing with 5, 2 plus 5 is 2 plus 3 is 5. That is 2 by 5 is to 3 by 5. That means which is equal to 0.4 is to 0.6. That means 40% movement we need to give to BA span, 60% movement need to give to BC span to make it 0 there. That means x equal to 40.4 times of 12.5. So x equal to here 0.4 times of 12.5, that equal to how much? 5 Newton meter. And y equal to 60% of 12.5, which is equal to how much? 7.5. Okay.
7.5.
7.5. So that means now the structure will become like this. I will draw. See, by applying x moment 5 here, the carryover will come here. How much? 2.5. Here by applying 7.5 anti-clockwise, will come here 3.75 anti-clockwise. Now you can see 5, 7.5, 12.5 anti-clockwise and 12.5 clockwise. Net external load is not, net external couple is not there here now. It becomes 0. So now moments will become like this. End moments 22.5 and 2.5, that is 25 anti-clockwise. This side 10 clockwise, anti-clockwise 3.75 means clockwise 6.25. Internally no movement here at support. Net becomes 0. So now this is the structure, analyzed structure. 30 kilonewtons, 3 meter, 3 meter, 20 kilonewtons, 2 meter, 2 meter. Now other support reactions and all, with this we can find out very easily. Okay, suppose internal force, if you want to find here, you can find. See here, there is 5 here. How much here? Internally, if you see here, 5 moment we are applying here. That means anti-clockwise. One second. Not 5 actually. That is, see here, 5 means 5 anti-clockwise means here like this. 5 Otherwise we mark here. Here fixed moment, how much is there? 22.5. This one, and anti-clockwise 5. Here fixed moment, clockwise 22.5, anti-clockwise 5. Fixed moment 10. Distributed moment 7.5, anti-clockwise. So internal moments, if you want to see, it will be like this. It is 22.5 clockwise, anti-clockwise 5 means 17.5 clockwise.
సార్ అక్కడ బి పాయింట్ దగ్గర 4 మూమెంట్స్ వచ్చాయి కదా, అది ఎలా వచ్చారు మళ్ళీ ఇంకోసారి చెప్పరా?
ఇది ఫిక్స్డ్ మూమెంట్ 22.5 10 ఇది డిస్ట్రిబ్యూటెడ్ మూమెంట్ x and y 5 and 7.5 5 7.5 ఇది అర్థమైందా? ఇది 22.5 అనేది ఫిక్స్డ్ మూమెంట్ అన్నమాట. 22.5 and 10 అనేది ఫిక్స్ చేసాం కదా ఫస్ట్ మనము. ఫస్ట్ ఫిక్స్ చేసినప్పుడు బి దగ్గర ఎలా ఉన్నాయి మూమెంట్స్? 22.5 and 10 ఉన్నాయి కదా.
అవును సార్.
తర్వాత డిస్ట్రిబ్యూట్ చేసిన తర్వాత 5 7.5 డిస్ట్రిబ్యూట్ చేసాం యాంటీ క్లాక్ వైజ్ లో. ఎందుకు అలా చేసామంటే నెట్ 12.5 క్లాక్ వైజ్ ఉంది, నెట్ యాంటీ క్లాక్ వైజ్ 12.5 ఇచ్చేయాలా. ఏ రేషియోలు ఇవ్వాలా? 0.4 0.6 రేషియోలు ఇవ్వాలా. ఏంటి ఆ రేషియో? స్టిఫ్నెస్ రేషియో అనమాట. బిఏబిసి యొక్క స్టిఫ్నెస్ రేషియో అది 0.4 0.6 అనేది ఫ్యాక్టర్స్ అనమాట, డిస్ట్రిబ్యూషన్ ఫ్యాక్టర్స్. ఇవి డిస్ట్రిబ్యూషన్ ఫ్యాక్టర్స్ అనమాట. సో 40% లెఫ్ట్ స్పాన్ కి 60% రైట్ స్పాన్ కి ఇస్తే 5 and 7.5 అయినాయి అనమాట. అవే 5 and 7.5. నెట్ వచ్చేసి 22.5 and 5 నెట్ ఈస్ 17.5 and 10 and 7.5 net is also 17.5. So these are internal forces. Okay, 17.5 17.5 internal movement. Okay, this is internal couple. Okay, now we can find reactions also very easily. Here
sir
chepma
sir, C దగ్గర 6.25 ఎక్స్ప్లెయిన్ చేయరా?
10 minus 3.75 ma, clockwise 10 anti clockwise 3.75. యాంటీ క్లాక్ వైజ్ 3.75 ఎందుకంటే 7.5 లో క్యారీ ఓవర్ అనమాట. ఇది 5 లో క్యారీ ఓవర్ 2.5 క్యారీ ఓవర్ ఎందుకంటే ఫారెన్ కి 50% ట్రాన్స్ఫర్ అవుతుంది కాబట్టి. ఓకే మా. నౌ we can draw we can find other reactions also for this. See how to find the reactions. (30 20) 3 meters 3 meters 2 meters 2 meters. Here anti-clockwise 25. Here clockwise 17.5, anti-clockwise 17.5, clockwise 6.25, 6.25, right. Now finding reactions are very simple. See, as 30 is midpoint load, for 30 15 will come reactions like this, and 25 anti-clockwise 17 point clockwise. In the span AB span, if you observe AB span, 25 is anti-clockwise, 17.5 is clockwise, net is anti-clockwise 7.5. So anti-clockwise 7.5, we need to give counter-clockwise, counter for that clockwise. How much? 7.5 by 6, 7.5 by 6. That is the, we are forming a couple for imbalancing of this one. 25 anti-clockwise, clockwise 17.5, net is anti-clockwise 7.5. So for that clockwise 7.5 we need to give. So span is 6 meters, that's why 7.5 by 6. Similarly for BC span also, 21st will split into 10 and 10 because of central load, and anti-clockwise 17.5, clockwise 6.25, Net is how much? 17 minus 6, 11, 11.25. So anti-clockwise 11.25. So we need to have clockwise couple. So 11.25 by 4. 11.25 by 4. So now net reaction here is 15 plus 7.5 by 6. How much?
$97.5.
Huh? 15 plus 7.65 by 6. 16.25. Okay. Then here 10 minus 11.25 by 4 because it is downward minus. Okay. 10 minus 11.25 by 4. 6 point?
7.19.
7 point? 1875. Then this total, 4 total. 15 plus 10 minus 7.5 by 6 plus 11.25 by 4.
26.56.
26.5625.
5625.
These are the reactions, okay? That means reactions are like this. .25, 26.5625, 7.1875, 25, 6.25, 30, 20. These are the reactions and loads, okay? Actually, no need to mention here internal moments at B. Internal moment at B is 17.5. Internal moment at B is 17.5. If you want, you can mark, otherwise you can leave it, okay? So now we can draw shear force diagram. Shear force upward 16.25, straight 30 down. 30 down means it go up to 13.75 because minus 30. Then it goes straight. Then plus 26.5625. Then how much it is? Minus 13.75 plus 26.5625.
12.8125.
12.8125. 8125. Then downward 20. That means minus 7.1825 and go like this and join here. This is the shear force diagram. Then bending moment diagram also you can draw. Bending moment. Here 25 anti-clockwise left. That means negative. Minus 25. Then you can calculate at see D point. D point, what is the moment? Bending moment, tell me. Minus 25 plus 16.25 into 3. How much? Minus 25 plus 16.25 into 3. You'll get at
23.75.
23.75. 7?
5.
75. Okay. Then here, you know, moment clockwise 17.5. Right clockwise means negative. Negative 17.5 at B. 17 point, minus 17.5. Okay, at E point, if you want to calculate, so at C, you know, 6.25 negative, because right side clockwise negative 6.25 minus 6.25. At E you can find minus 6.25 plus 7.1875 into 2. How much?
Eight point one three.
125 or 13 na?
125.
125. This is minus plus minus. Okay. Now you can see there is a relation between this shear force and bending BMD. How? See, positive shear force is there means positive slope is there here. Negative shear force means negative slope is there like this. Then positive shear force means again positive, constant. Negative means again negative, like this. Okay. So you can observe that. Okay. And yeah, these are shear force diagram and bending moment diagram. Finding reactions, finding drawing shear force diagram, bending moment diagram. Before that, finding movements. These are very important things. Okay. Same problem we can do in tabulated format. Tabulated format, if you do, we'll see that. What is that? Tabulated format. So this is the structure. 30, 20, A, B, C, 3 meter, 3 meter, 2 meter, 2 meter, 30 kilonewtons, 20 kilonewtons. Okay, EA. So we need to draw a table like this. And like this. Like this. A, B, C. Here span BA. I mean before that joint B. Spans are BA, BC. Stiffness K. 4A by 6, 4A by 4. Sigma K. 4 by 6 plus 4. Sigma K for this total. How much? 4 by 6 plus 4 by 4. Then distribution factor equal to K by sigma K, which is equal to how much? 10 is the 24, or otherwise 1 plus 4 by 6. 10 by 6, right? 10 by 6. So K by 4 by 6 by 10 by 6. How much? 6 gets cancelled. 0.4. 4 by 4 by 10 by 6. How much? 4 by 4 by 10 by 6. So 0.6. You can check it. Okay. These are the distribution factors. So 0.4 and 0.6. Then fixed moments here. We have calculated here. What are those? 25, 17.5. Sorry. 22.5, 22.5, 10 and 10. That is anti-clockwise 22.5 and clockwise 22.5. Anti-clockwise 10 and clockwise 10. Now here we need to make it 0. 22.5 minus 10. Net is 12.5. 12.5, that means here net is 12.5. So minus 12.5, opposite we need to apply, into 0.4. How much? Minus 12.5 into 0.6 is how much? See, 22.5 minus 10 equal to 12.5. For 12.5, we need to apply minus 12.5 in the ratio of 0.4 and 0.6. That is this one, how much? 5, right? And this is minus 5 and minus 7.
7.5.
So minus 5 minus 7.5. As foreigners are fixed, carry over 50% will come like this, minus 3.75. So finally, so now it is minus 25, minus 25. This one is 17.5. Here minus 17.5 and 6.25. These are the moments. At A, minus 22.5. That means anti-clockwise minus 25. At A. At B, 17.5. At C, 6.25. See here, sign convention also. See here, left to negative means, I mean, this is anti-clockwise, this is clockwise, this is anti-clockwise, this is clockwise, right? Left side anti-clockwise, right side left side anti-clockwise, right side clockwise is what? That is actually hogging. So these are the fixed moments, okay? I mean moments at the ABC. This is also hogging moment, negative moment. This is also negative moment. This is also negative moment. This is also negative moment. Negative means hogging. That means these moments creates the beam bend in hogging manner. Hogging means like this. So to make it bend like this, left side anti-clockwise we need to apply, right side clockwise we need to apply. That's why this portion you see anti-clockwise left, right clockwise means hogging. So hogging means negative movement. Okay. Sagging means like this, opposite. Okay. So this plus to minus, and here this minus different. Okay. Sign convention of hogging and sagging is left anti-clockwise, right clockwise. That is hogging movement. Hogging means negative movement. Here also left anti-clockwise, right clockwise is hogging movement. ఇందులో డౌట్స్ ఉంటే అడగండి. ఏ స్టెప్ లో అయినా, ఏ స్లైడ్ లో అయినా.
Sir.